8 calculus students at Stoughton High must make their way to school. Each of them has a unique set of skills that make them particularly inefficient at arriving on time. Here are their stories. This is Sadie. Unfortunately, Sadie has forgotten how to drive. So instead, she decides to ride her bike to school. Commute takes her approximately 47 minutes. Her velocity is shown by this graph. How far from school does Sadie live?
To figure out how far Sadie lives, you have to figure out the area under each one of the curves. Break up the curves into trapezoids, triangles, and rectangles. Then add up all the areas and divide by 60 to get the total distance. This all equals 2.
Jacob wakes up late, and he decides to make waffles for breakfast. After realizing he would be late, he decides to ride his moped to school. On his way, he encounters a most unfortunate pedestrian attempting to cross the street. His velocity during this trip is modeled by the piecewise linear function whose graph is shown. Find Jacob's acceleration at time t equals 3.2 minutes and his total distance traveled.
To find Jacob's acceleration at time t equals 3.2, you need to find the slope of the line that is highlighted in yellow. You use these coordinates. To find the slope, you do change of y over change of x. This equals negative 30 over 0.4 or negative 75 miles per minute squared. To find the total distance traveled, you have to find the integral of the graph or the area under the curves. To do this, break up each curve into squares, rectangles, triangles, and trapezoids. This equals 156. To get the distance, then, you have to divide by 60, which equals 2.6 miles.
This is Ethan. Every morning, Ethan rides his kick-ass scooter to school. While on his way to school one morning, he sees a couple of punk kids at the skate park and decides to show them up.
You gotta keep them separated.
After looking super cool, Ethan leaves the skate park and unfortunately gets hit by another student on a moped. But finally, Ethan does make it to school. If Ethan's trip is modeled by the function y, and he lives 0.6 miles from school, on what time intervals is he accelerating? And in the first minute, does his velocity ever reach 2.5 miles per half hour?
Based on the equations, you can tell he's accelerating at the intervals of x is less than 1.5 and x is greater than 8. Using the time interval, does he ever reach 2.5 miles per half hour? If you use the mean value theorem, you can determine if he ever reaches 2.5 miles per half hour. First, convert the minutes into half hours by dividing by 30. Then plug in the endpoints for each function to create a secant line. Using the 2 points you found and then dividing by the change of time, you'll determine the average velocity he travels. The mean value theorem states that Ethan traveled at an average velocity of 5.43 miles per half hour in the interval between 0 and 1.5 minutes. The answer is yes. Yes, Ethan does at least travel at some point of the trip 2.5 miles per half hour, based on the mean value theorem.
Claire decides to skip to school. On her way, she realizes that she forgot her calculus book and turns back to get it. After she is further on her way to school, she realizes that she only grabbed half of her book. Once again, she has to go back before hurrying to school. Using the graph of her position in miles versus the time in minutes, what is the difference in the magnitude of Claire's velocity the first time she headed for home versus the second time?
To answer the following question, you need to take the slope each time she returns home. The first time she returned home is resembled in red. The second time is resembled in yellow. To find the slope, you take the change in y over change in x. Using the points for the first time she returned home, you find that she traveled at 0.06 miles per minute. The second time, you find that she travels 0.0725 miles per minute. Take the difference between these two, and you find out she traveled 0.0125 minutes faster the second time she returned home.
One morning, Dylan's mom asked him to walk the dog. While walking, he realized that he was running late. So, he hurried home and threw his dog inside and proceeded to grab a pogo stick and hop to school. If Dylan lives 0.7 miles away, how long does it take him to get to school, and what is his maximum speed?
Dylan's position is resembled by this equation. If you plug this equation into your calculator, you'll get this graph. If I live 0.7 miles away from school, how long does it take me? Well, at first you need to find the intersection of that 0.7 in this graph. The intersection is at x equals 0.919477517. 0.9194 is both equivalent to 55 minutes. If I left at 7 a.m., I would arrive at 7:55. To find the greatest velocity, you need to take the derivative of my position equation. This graph resembles the derivative of y. This is the velocity of my travel. To find the greatest speed, you need to find the maximum, which is circled here. The maximum is at x equals 0.71 hours.
This is Noah. Noah wanted to ride his bike to school, but unfortunately, his bike is broken, so he has to settle for riding a trike to school. On his way, he encounters two stop signs at time t equals 15 and at time t equals 22. At time t equals 28, he encounters a nail in the road that flats one of his tires. This dramatically reduces his rate of travel, causing him to run late to school. At time t equals 33, he pulls over and he injects himself with an EpiPen for a shot of adrenaline. How much time is saved by using the EpiPen?
To figure this out, you need to find the distance traveled after he used his EpiPen. The distance traveled is the area under the curve, which is now shaded in red. If we zoom in, we'll see that it is a rectangle with a base of 4 and a height of 7. Multiply these two numbers and you'll get a total distance traveled of 28. If Noah doesn't use his EpiPen, then he travels at a rate of 1. To find how long it takes, you divide the distance by the rate, which will give you 28 minutes. Then add that at the point where he stopped to get the expected time of 62 minutes. With the expected time of 62, you will subtract the real time of 40 to get how much time he saved. You'll get that he saves 22 minutes by ejecting his EpiPen.
Johnny is out plowing his field one morning, like any other morning, when all of a sudden he realizes that school is about to start. In order to not be late, he puts the tractor into high gear and speeds off. Sometime later, Johnny puts the tractor in the parking lot and arrives at school safely. Johnny's position in reference to the field he was plowing is modeled by the parametric equations x equals t cubed minus 3 halves t squared minus 18t plus 5 and y equals t cubed minus 6t squared plus 9t plus 4 from 0 to 2.5 where t is in hours. Find Johnny's acceleration vector at t equals 1.5.
To find acceleration, you need to take the second derivative of each position equation. The first derivative of x of t is 3t squared minus 3t minus 18. And y of t's derivative equals 3t squared minus 12t plus 9. Now let's take the derivative again. The second derivative of x is 6t minus 3. The second derivative of y equals 6t minus 12. So plug in 1.5 t for every t in the equations. For the x function, the second derivative of 1.5 equals 6 miles per hour squared. For the y function, the second derivative of 1.5 equals negative 3 miles per hour squared. So then, acceleration vector equals 6 and negative 3.
This is Lucas. Lucas decides to embrace his true hipster self by riding his unicycle to school. It is a much slower mode of transportation than a car, but he only lives a half-mile away, and it will be worth it when the other kids see how cool he really is. However, when he is almost to school, he falls and is knocked unconscious. Suddenly, he wakes up and realizes that he is late for school. He proceeds by crawling his way there.
It's Saturday.
Wait, where's Lucas?
At least.
At least I mean you got that.
Try again.
You gotta redo it. I don't know how to wave.
You forgot your line? Is that your complaint?
Put you in back.
Yeah, we should definitely put me in back.
Yeah.
Okay, who's good at waving? Dylan, get up here.
Dylan, get up there.
Keep an eye on it with me.
I didn't realize this was the hardest part.
Actually, waving is the hardest part.
Yeah. I think that's like
Okay.
Good practice.
For 10